Assalamualaikum and good day everyone. Today we would like to present our assignment for discrete mathematics. First of all, let me introduce our team members. This presentation is prepared by Nur Aifa Kazrina binti Muhammad Ridwan, Nurul Huda binti Ahama, Zaizwani bin Zailani, Nurul Afika Farzana binti Abdullah Faizi, and Siti Nur Syahira binti Aris. Each of us contribute to different part of this assignment. First of all, I want to present about introduction of discrete mathematics. We have two problem to solve. Problem one is modeling an integrated road network connecting several urban zones using a weighted graph. The objective of the road network problem is to determine the minimum spanning tree (MST) that ensure full connectivity with minimum total construction cost. Kruskal and Prim's algorithms are used to identify the optimal solution and avoid redundant routes. Problem 2 is focusing on represent a university course at system using a tree diagram. This problem help to identify important tree characteristics such as root, edge center, leaf, nodes, and height. Overall, this PBL aims to enhance analytic thinking, problem-solving skills, and teamwork of the application of Discrete maths concept. So, this is our question. Optimal road network planning. This question focuses on designing an efficient road network that connected several urban zones. Each urban zone is represented as a vertex, while each road connecting the zone is represented as a edges. Different construction conditions cause each road to have a different cost. The road network is represented using a weighted graph to clearly show this cost difference. The main goal is to ensure that all urban zones are connected while keeping the total construction cost as low as possible. A minimum spanning tree (MST) is used to eliminate unnecessary or redundant road connection. We need to use a Kruskal and Prim's algorithms because it helps us to identify the most cost-effective road network. So, let me explain more about Prim's algorithms. Prim algorithms is used to find the minimum spanning tree of a weighted graph. It starts from one chosen vertex. At each step, it selects the edge with the smallest weight that connect a vertex inside the tree and to the vertex outside the tree. The selected edge is added to the tree without forming a cycle. The process continues until vertices are connected, and the final result is a minimum cost network. So, this is the answer of that question. The answer of question 1. So, you can see step by step, and you can total all the prims number, so you can get the final number.
So I will explain about Kruskal's algorithm. Kruskal's algorithm is used to find the minimum spanning tree (MST) of a weighted graph. It considers all edges in the graph. All edges are sorted in ascending order of weight. The algorithm selects the smallest weight edge first, and edge is added only if it does not form a cycle. The process continues by adding edge with increasing weights, stops when all vertices are connected. The result is a minimum cost spanning tree. So, for this task, we were assigned to connect 9 urban zones ranging from the city center to the recreational area with the minimum possible construction cost. We apply Kruskal's algorithm by first sorting all available route costs in ascending order. We started by selecting the cheapest paths, which are D to E and G to H, both costing 1 unit. We then proceed to pick roads with a cost of 2, specifically B to C and B to D and H to I. Next, we added roads C to F and E to G, which cost 3 units each. Finally, to ensure the city center was connected without creating any cycles, We selected the road A to C with a cost of 4. By skipping redundant roads like G to I, we achieve a fully connected network with a total minimum cost of 18 units.
So for the question 2, cost prerequisite structure, this question focus on representing a heuristic cost prerequisite system using a tree structure. The tree diagram illustrate the hierarchical relationship between foundational and advanced course. Each node represent a course, while it indicates a prerequisite relationship. Course at the higher level must be complete before progressing to the lower course. This structure helped in understanding course depending and planning academic pathway efficiently. So this is the three analysis course that we use is algorithm, mathematics, English, network, computer, calculus, logic, Islamic, hardware, programming, operating system, tafsir, hadith, sirah, database, and security. At the top of the tree, we have algorithm as the root node, which represent a core course that connects to several other subjects. From algorithm, the tree branch into courses like mathematics, English, network, and computer, showing that these subjects are related or required before moving further. For example, under mathematics, student needs to take calculus, and from calculus, they need they must complete operating system which shows a clear learning progression. Under the English, the course branch into logic and Islam. And Islam is further divided into tafsir, hadith, and sirah, representing more specific subject. On the computer branch, students first learn hardware, then move on to programming, and finally advance to database and security. This analysis helps us identify the parent-child relationship between courses and understand how knowledge moves from general concept to more specialized topic. Overall, these three structures make academic planning clearer and ensure students follow the correct order when taking courses. So the first question is identify the root course in this persecuted tree. The answer is the root course is algorithm. B. All the ancestor of course X. First one is English. Second one is algorithms. C. Identify all leaf course. The first one operating system, then logic, network, tafsir, hadith, sirah, hardware, database, and security. D. Determine the height of the prescribed tree. The height of the tree is 3.
Okay, so this slide shows a binary tree, which is a structure where each node can have at most two children. The root node here is algorithm, representing step-by-step instruction used to solve problem efficiently. From algorithm, the tree branches into mathematics and English. Mathematics lead to calculus, which is important for problem solving and analysis in computing. From calculus, we have operating system which manage computer resources like memory, processors, and files. English branches into logic and network, logic connected to Islamic studies, then tafsir, hadith, and sirah. Network connects to computer, which branches into hardware, programming, database, and finally security, which protects system and data. This tree shows the hierarchical connection between subjects, from general topics at the top to more specific ones at the bottom. It also demonstrates how a binary tree organizes information efficiently, making it easier to understand relationship between different subjects. So for the conclusion, This problem-based learning task successfully applied discrete mathematics concept through two different problem scenarios, which is in the first question, we solve graph theory and minimum spanning tree algorithm, namely Kruskal and Prim were used to determine an optical root network that connects all open zones with minimal construction costs. This approach ensures full connectivity while avoiding redundant routes. In the second question, a coarse circuit system was represented using a tree structure to clearly show the hierarchical relationship between foundational and advanced courses. Important tree properties such as root and sister of a specific course, leaf nodes, and the height of the tree were identified. Overall, both questions demonstrate how graph entries can be effectively used to solve practical problems in planning and education system. That's it for me. Okay, that's it from us. Thank you for watching.